Hi, everyone. Thank you so much for attending. We will start session 5 now. And the first speaker is Manzar Dale from MIT, and he's going to be speaking about information sale with externality.
Thank you, Osman, for the introduction. Thanks for the organizers for such a lovely event, and really pleasure to have it in person and see people from many years before. So I wanted to make some remarks today about information sale with externality. And this is work that I've been doing for several years right now. These are some of my students that have been involved in this work, and in collaboration also with Professor Bonatti from MIT, from economics at Sloan at MIT. So as we've been hearing in this workshop, for example, it's very clear that machine learning is entering just about every domain, and it's actually transforming the way companies are operating. I mean, data science is entering the world, changing the value propositions of companies, allowing us to solve problems that we couldn't solve in the past. And it's almost everywhere right now, machine learning for X. But one thing that we don't pay a lot of attention to is that, and we do, but we sort of have to kind of start thinking about, is the actual data that we operate on. The data has become a major economic power. And in many ways, it's an economic power that we don't know how to value. And has, I would say that, for example, personal data is the new oil of the internet and the new currency of the digital world. That's many years back from the European Consumer Commissioner. I like that statement in indicating how, in fact, data is becoming just about a commodity of sorts, right? But if you go to buy data, you don't know how to value it. If you actually ask Bloomberg, how do you value data? Well, Bloomberg sells operational data to stock markets and so forth. That's valued in a certain way. But when companies go to buy data about customers, data about products and so forth, they get hit by the idea of how valuable this data set is, and why should I be paying tens and thousands of dollars for this data set? So Bloomberg doesn't have an efficient way of creating a market, and certainly Nielsen and Reuters follow suit in whatever Bloomberg does. So we don't have a really clear market for understanding the value, the economic power of data. You get markets like 23andMe, which I would also say this is probably in the next decade going to be one of the most powerful things that we're going to be focused on, which is genomics. I think we're going to be stopping talking about regular data and just be talking about genomics, and everything we talk about computing right now, we're going to be talking about genomics. 23andMe is creating a repository of enormous amount of genomes. And they're doing it in a very interesting market. You pay to contribute your data. You pay $50 and you send them your data. Like to get myself a market like this, where people pay me to give me stuff. Of course, in return, you give them a service, but the service is literally running a clustering algorithm. That service is costing them absolutely nothing. But we got used to this concept of companies collecting our data in exchange of service, right? And not valuing the detail of the data. Of course, one genome, how important can that be? Aggregates of genome, how can they be? But when you have the collection of such genomes, I think you have a lot of power. Okay. Another aspect of this is understanding, for example, when we had the Equifax breach, 150 million records of finance were made public. What is that? What's the damage value of all of this? We actually don't know. When the stock market crashes, we at least have an estimate of how much we lost. We don't know how much we lost when that happens. I don't even know if my data record was in that set, how that impacts me personally. I don't know how to value that. Similarly, in Cambridge Analytica took data from Facebook, they bought it, and they they attempted to impact the outcome of an election. Until today, we don't have the counterfactual of knowing if Cambridge Analytica did not exist, whether election would have been different. We don't have that answer. But certainly, if that did happen, that has tremendous impact on our society. So how do we value this type of a data breach? And I want to say something a little bit about things that we don't think about a lot in causality and causal inference, is that the right data is really important to make decisions. I had a few slides on COVID-19 talking about how intervention, for example, was important, and the absence of data did not allow us to come up with the right policies. I removed them because I know I have 15 minutes. But I do want to say something about a project that we have in sub-Saharan Africa working with poor farmers. And one of the important aspects is this development project is trying to help farmers improve their production. And to improve your production, creditors have to come in and invest in technologies for you to apply. But the creditors don't know what the upside, well, first, they don't trust the farmers. Second, they don't know what the upside of the intervention is. And without knowing what the upside, they don't know how to take the risk with the farmers. So we need to predict the upside. That's a causal decision. If the farmer applied these types of interventions, then they increase their yield by a certain amount. It's sort of like these tensor completion problems. The difficulty in all of this is that the valuable data is not available. Companies that, farmers that have actually created a situation where they are improving their production, they're using the seeds and fertilizers and the irrigation and the satellite images and so forth, are not sharing that data. That data is very valuable. And if you tell them to share the data, they would say, well, but we compete in the down market. And by competing in the down market, this whole work that I've done has gone to nowhere. So that means that we have to value the data in order to share it. So how do we actually provide proper valuation for this data? And we do have different types of market out there. Of course, the stock market, we understand it's a clearing market. The ad auctions market is sort of a digital market, but it's not entirely a data market in that it's predicated on data, but it is an auction market in that it's still, you're selling one piece of real estate on the website. And of course, there's a lot of data behind it, so that's very interesting. Maybe the only honest-to-God market that is the data market today is the prediction market. Because you actually do, you provide your prediction and you get paid or not paid based on how well you do your prediction. But this is very aggregate. Prediction market is your opinion of something. Nobody cares how you arrive to that decision. So it's a very high level, I would say, nevertheless, a data market. What we need is a market that looks like this, a marketplace where sellers can come in. The sellers provide their data, they post their data sets, and then buyers come to the market with particular tasks. I want to predict what my inventory should be during the back-to-school season. And I want to calculate this using a particular machine learning algorithm. So I want to understand how to improve my prediction. And well, the market then is going to collect some money from the buyer, and that money is going to be based on how well they do in terms of improving their prediction, and distribute that among the sellers. So how is that process going to work? Now, in 2018, we wrote a paper on the systems aspect of this market, which I'm not going to go into today, but it describes really the details of what the buyer's sort of restrictions are, what the seller's restrictions are, how a market can actually make sense in terms of trading issues and so forth, trading data and so forth. But I want to step away a little bit and give you something simpler and highlight some of the interesting questions. And before that, let me highlight why a data market is different than a regular market, okay? So the first thing that is important is that data can be sold to multiple people. It can be reproduced at a zero marginal cost. That means that I sell the data to one person, I sell it to another person. Right away, I'm creating externalities, competition between the two, which is very interesting. I cannot sell my house to two people, but I can sell the data for two people. So that's a very different type of a market for this. In general, the importance of a data set to a particular task can be combinatorial, in the sense that, if I have N people posted their data sets, and I haven't even described the format of that, what can help this particular prediction task can be a combinatorial combination of these things. So there's a complexity aspect that grows very quickly when you're thinking about these digital goods. People are using the data for a lot of different reasons. Some people want to predict. Some people are trying to forecast weather. Some people are trying to sell more products, right? And so how do you specify the value that you're getting from the data? What you cannot be selling is the data on its own, because the data on its own may make no sense to me, but may be a huge advantage to somebody else. It all depends on the task that we're looking at. There is no inherent value in the data itself. It is only important with respect to the task that you're using. So the task has to be stated, but these tasks are really very vast. And the question, how do we capture that in the market? The other thing is, of course, you have, and this is part of the system design problem that I referred to, The market, at the end of the day, has to do the matching between the sets and the task. The data cannot be transferred to the buyer, because if you transfer it to the buyer takes it and does other things with it. So the authentication, the privacy, all of that stuff has to be the task of the market. That actually brings up a whole bunch of issues that need to be dealt with. And finally, I would say that the externality is a very important component. Externality means that if somebody buys the data, how does that impact the other firm that is competing with them? So I want to focus a little bit on this issue and show you how some of the analysis with externality can bring up some very interesting properties of these markets. So let me kind of just abstract the view this way. So you think of it that you have a data intermediary, it's the market, gets information from consumers and provides it to different firms. The firms use this information to then design products to sell to the consumer. And that's, you have this entire cycle feedback system that we have. Of course, in this part over here, this is what economists have studied for many years. You know, the Corno competition and different types of competition lie in this part over here, okay? The part that we want to study is this part over here. If the data intermediary got some information, aggregated it, I'm not going to worry at that path right now, how do they provide this to these firms that are competing in the down market? So let me give you an example that highlights this problem. It's called the hoteling problem. It's rather simple. It's a hoteling problem, and I make it a restaurant problem. Okay, so there are two restaurants that are going to be building their facility on this line. Okay, and this describes the distribution of customers. Okay, the mean of the distribution is X, and they don't know what X is. So they both want to place themselves on this line. Okay, so there may be two fancy restaurants that want to be on this line. And the point is, of course, not knowing where X, if you place yourself on Z1 and Z2, then you get the market share based on the distance to you. People that are closest to you will come to you. So the market share of the market then kind of splits like this. Restaurant number 1 gets everybody in this side, and restaurant number 2 gets everybody in this side, okay? So it's the incentive of each one of these firms to know where that distribution is, what that distribution is. So they want to buy it from the market. The market will sell that data, but it wants to maximize either welfare or revenue. Just think in terms of maximizing revenue, the market would like to sell it to the more profitable business. But the value of the business is not something that the market knows. So the value of the business is not just the market share, but it's multiplied by a factor over here in terms of what the profit is going to be for that particular business. So maybe McDonald's is actually a much higher profit margin company, and as a result, the market may then want to give them the better information, have them have the better market share, because it can collect more money from them. But the market doesn't know their valuations. So now we have this distributed information structure. The market knows where the mean of the concentration of the customers, but it doesn't know the valuations. The firms know their valuations separately, privately, but they don't know what the mean of X is. We want to set up a market to exchange all this information to make it work. And that's what a mechanism designed for this problem looks like, okay? So the main idea is that the market observes a theta, or X in that example. The firms have V1 and V2, and we're going to think of this as a repeated game. So different firms come, different state of the world occurs. A market mechanism basically is based on an auction. So what happens, these firms are going to auction this information. They're going to bid for this information. I'm going to pay this much to get X. Okay, so they bid T1 and T2. They pay a certain amount, P of T, that is designed by the market, and they are told where to go directly. That's kind of the market does. It says you go to Z1 and you go to Z2, and the market does it to try to maximize either welfare or revenue. And I know that, how much time do I have? Okay.
What's called the monitor there based on?
Monitor is in the negative. Okay,
Oh,
I'm
really?
just kidding. What does that mean? No, it's still positive. Sorry, I'm just kidding. Okay. So I'm going to skip the example that I'm going to show you. I'm going to make some comments here and view these things as abstractions. Don't view them as a picture. So what happens in that example? they're so we can set up a mechanism. The mechanism gets complicated as you complicate these types of questions, but what the mechanism needs to be to satisfy two properties. One is truthfulness, and the second one is obedience. What does that mean? So we want the mechanism. You want to set up the payment structure and the allocation in such a way that the firms are incentivized to bid their actual valuation, not to lie about that valuation. I cannot come to the market and say, you know what, I'm going to make that much profit over my market share. You have to bid the actual valuation. That's in the design of the payment function. That's sort of like Meyerson's type idea. And the second thing is the setup of the market is such that when the data market recommends, the intermediary recommends where you go, you should follow. That's what's called obedience. These two constraints combined is what's known as incentive compatible, okay, in economics. It turns out that's really interesting in this example that I showed you, and think of this example as extreme. Either I'm going to tell you to go to the right place or the wrong place. Don't think of it as a continuum. Same hoteling example. It turns out really interesting scenario in plotting the region of allocation under these mechanisms, okay, optimal mechanisms. So, for example, you see situations over here when the valuations, when the valuations are both high and comparable, everybody gets the right information. But there are situations where your valuation is less than the second person's valuation, and you are told to go exactly in the wrong direction. And you are told to go in the wrong direction, and you still maintain that you want to participate in that market, and you pay for that information which is wrong. Of course, you don't know that you got the wrong information, and you have no way of extrapolating that because you don't know what the state of the world is. And that's actually part of these mechanisms that are quite interesting. In the maximum revenue case, there will be situations where both people actually given wrong information. So then when what's known as their virtual valuation is negative, and they're comparable to each other, it is actually better for the market for these types of valuations to say both of you are gone in the wrong place, so that in general, the reservation price increases when new people come into the picture, right? So these are some of the nuances that you see in trading information. Another aspect of this that's actually quite interesting is that, again, I didn't show you the numerical example, but this indicates, alpha indicates an increase in competition. So when the competition between the two players, the two firms, is higher, what happens is that they both get less value when they compete higher, okay? They get less value. But the amount of money that the market collects is higher. The market prefers to have two competing firms, and they capitalize on this to collect as much more money than they would if they were not that competitive. And yet the two don't benefit as much. So that's an interesting aspect of the problem. And you can see that, you know, in general, in terms of increase, if you increase the competition, you increase the revenue collected, but you decrease the social welfare. Anyway, I'm just presenting this example to highlight, and I know this is not enough time, to highlight that sale of information is different than a sale of a house or a sale of an actual commodity, but in this setup, you actually derive the value of that information. And you have a systematic way of deriving the value of that information. So as a result, then you can sort of begin to think about how the first market that I described to you can be set up in such a way that there's a trade, actually, or a posted price, and the price kind of evolves over time based on the importance of a data set, but when the trading is done through a mechanism that is both, that is incentive compatible. Okay, so I just, in conclusion, I want to say that there's a principled way of allocating information. Externality, of course, makes things much harder. If the problem had no externality, then you solve the problem one buyer at a time. That actually is much easier as a situation, But when you have externality, the problem is a lot more, as it gets into the nuances that I described. And of course, to actually set up an actual market, there's a lot of other stuff that has to happen that I just described earlier, but there's certainly questions of aggregation and other issues that I will leave. And I'll stop here. Thank you.